First of all, we will start with some trigonometric identities. Okay, trigonometric identities that we will possibly need, because we know like trigonometric functions, we can rewrite one function in terms of the other function. We have lots of like formulas, properties, identities that we can like rewrite one expression in terms of the other, okay, using all of these properties. That means let's check. First of all, Pythagorean identity. Okay? That's what sine square of x plus cosine square of x is 1. That we really have to know this. I will box it. Okay? We really have to know that formula. This is, of course, really helpful because what we can do, we can rewrite sine square of x or cosine square of x in terms of the other function, the cosine or sine, respectively. Okay? That means also, please make sure that you know where these formulas come from. Okay? And of course, we like the square, we like the even exponents, because everything is on, I mean, not everything, but lots of formulas are based on the Pythagorean theorem, which of course the squares are involved. Okay, and just in case if we have a little bit higher power, like sine to the power of 4 of x, and we want to rewrite in terms of cosine, of course, we will focus on the square and then another square. And this is sine square of x in terms of cosine. Or maybe to the power of 10. Again, we will focus on the square and the remaining power based on the powers property. Okay, that we can see how we can rewrite just in case if we will not like sine function, or let's say we will prefer cosine. Okay, that means you can, of course, always pause the video and maybe like make some notes and make sure that you know the formulas. Okay, the next one are the double angle formulas. That means double angle sine of 2x is defined as a 2 times sine of x cosine of x. Okay? Also the formula that we have to know. Cosine of 2x is a little bit different. Okay. Looks similar to the Pythagorean identity, but of course it's a little bit different because we have subtraction and cosine square of x is the first quantity. Okay, and cosine of 2x, okay, it's cosine square of x minus sine square of x. Also what we can do, if we will need cosine of 2x in terms of one function, like let's say sine, I will replace cosine square of x with 1 minus sine square of x. Okay, and then I will get this. I will get 1 minus 2 sine square of x. Or let's say I will replace sine square of x with 1 minus cosine square of x, then I will have this. Okay, the negative will be distributed. We will have 2 cosine square of x minus 1. That means also it's worth to remember like where these come from. Just 2 formulas. Okay, and now what we will do? We will take cosine of 2x. We will take a double angle formula for in terms of sine and in terms of cosine. And what I will do, I will solve both of the equations. The first one, I will solve for sine square of x, and the second one, I will solve for cosine square of x. That means I'm subtracting like from one side to another, and then I am dividing by 2. So we can see sine square of x could be also rewrite as a 1 minus cosine of 2x over 2, and cosine square of x is defined it's almost identical. Please note that for both of them, we have function cosine on the right-hand side, and for the sine square, we have minus, for the cosine square, we have plus, but they are the same formulas. Yeah, I'm just saying that this is not sine. And actually, these formulas we call half-angle formulas. That we have double angle and we have half angle, because we can see that x is half of this one. Okay, that x is half of this one. Okay, that means that's the reason that we call half angle formulas. Okay, And one thing, I can maybe remove everything just to see a little bit better. One thing that is important, we actually rewriting sine square of x in terms of the function that doesn't have a square. Okay, that means if we will think in terms of the integration, because that's our point, it's much, much easier. I mean, that's actually one of the way to integrate sine square of x. Okay, if we have to integrate sine square of x, we will always rewrite using the half angle formula and then integrate. Because like how can I rewrite, how can I integrate sine square of x dx? Yeah, it's sine of x times sine of x. We may try the u substitution, but I don't think we will cancel out everything. Yeah, that means this is the way. If you will see sine square of x, we have to rewrite in terms of double angle formula, and then this part is so easy to integrate. We will do it in a minute. Okay, that means this is one, that's the reason that we're doing this. Okay, Pythagorean identity, double angle formulas, half angle formulas. Now I have just one more slide with half angle formulas, just to show you like the half angle actually. Okay, that means this is this, and we have to remember if this is x, this is always half of this. And we know the formula, we know the rest of them. I don't have to explain this. The same for cosine. If this is x, this is 2x. That's me now, because my next line here, it will be, I don't remember, I think I put 3x. Can you tell me what angle will be here? If this is 3x, what angle I will have in the circle? 6x, thank you. That means that's it, because sometimes you will ask me later, oh, where does 6 come from? Or where the like, yeah, that means this is like double angle. Let's see if I almost circle the right place. Okay. I think I have 5 or maybe 5x. If I have 5x, what I will have here? I know it's probably a silly question. Yes, thank you. Thank you for answering. Of course, 10x. Let's see. Oh, I'm not, because I don't see this. Okay, that means just make sure that you know where the 6, 10, and 12 come from. And of course, any other value. It's always double. Oh, I should actually say this on the left-hand side is half angle. Okay, that means you will be confident with this. And then before we start integrating, I have just the basic integrals from calculus 1. Integral of sine of x dx, yeah, it's negative cosine of x. Integral of cosine of x is just sine of x. Yeah. Probably we have to always like take a few more seconds to integrate this, because it's so easy to like mix this up with the derivatives. That means if you're not sure like what is the integral of sine of x, like let's say you will say cosine of x, then you can try to differentiate. Derivative of cosine of x is actually negative sine of x. That means something is wrong, we need the negative. I'm just saying the negative is always confusing. Okay? But you can double check with your differentiation. And when we have additional coefficient like sine of 2x, sine of 3x, sine of 10x, right? We know how this will affect. We will still keep the same angle, because we remember we always keep the same angle. Angle never change, that angle, that input. And then since this is anti-differentiation, I will divide by this coefficient. Of course, the u substitution is behind. This is the result of the u substitution, but I can also say, like, let's say we have sine of 7x, but let me do this. What is the derivative of sine of 7x? Can you tell me? Derivative of sine of 7x. But okay, I don't know who is come. So what is missing? Do you remember what I just said? The angle must stay the same. This is the angle. Sine, because sine and cosine are the functions of the angles. That means, yes, derivative of sine of 7x is cosine of 7x and times 7, because it's derivative. Yes, now it's good. Yes, thank you. Oh, now let's practice. Actually, I can write on this side. What will be the antiderivative, I can say, of what's the integral of sine of 7x dx? Yeah. Integral of sine is negative cosine, the same angle, 7x, and since it's antiderivative, we will divide by 7. That means I'm just trying to show you that for the derivative we're multiplying, for the antiderivative we're dividing by that coefficient. Okay, that's just to make sense of this formulas. Okay, but the proper way is to use the u substitution, but we don't have to because it's the linear. Okay, that means let's start integrating. What we will see, as I said, we have lots of we have 6 trigonometric functions, and we can create like infinitely many combinations. Like I can multiply each like one with another one. I can divide them. I can square. I can cube. Like I can do lots of stuff. But in this session, in this actually section, we will focus on that combination, that product, sine of x times cosine of x. And they could be taken to the power of nm. Nm are just the natural numbers. Natural numbers are simply the positive integers. 1, 2, 3, 4, 5, 6, like counting numbers. Okay? That we do have sine of x taken to the power of something, I don't know, and cosine of x. And now cosine of x taken also to the power of another number. And what we may have, since they are positive numbers, integers, but we may have the only difference will make our decision will be based on if the n or m is even or odd. Okay, it could be even or odd, because that's the difference, even or odd. Okay, that means this is the difference. And now let's start with the case 1. I can call case 1. Both of them are even. Okay, both of them are even. That means x could be taken, sine of x could be taken to the power of 2, 4, 6, 8, and so on, and the same for cosine. Okay? Both even. And actually, if both are the even exponents, we will always use half angle identities. Always. No other method will work. Or maybe if we will try to reach some complicated, but yes, always, let's say in this section in our textbook is giving us this algorithm, half angle formulas. That means, let's see. I will start with just one because I can assume that cosine is taken to the power of 0 if we would like to keep that form, that pattern. But yeah, just sine square of x. Okay. And as I said a few minutes ago, we will definitely use half angle formula. So please remember, sine square of x, always half angle formula. And now I can factor out half, then we will see a little bit better. And now maybe you can tell me, what's the integral of 1 dx? What's the integral of 1 dx? Yeah, okay, because it's boring if I will solve everything. Oh, what's the integral of 1? Come on. Yeah, that's the reason that I want you. Yes, thank you, x, you have to help me. What's the integral of cosine of 2x? This is the question. Yes, 100 points question. I don't want to say $100 question. The integral of cosine is, cosine of 2x is sine of 2x over 2. Excellent, and you know where the 2 come from. Really good, okay. I think I type it. That's the answer. The only thing is, oh, hang on. The only thing is, this is probably good answer and we will accept it, but we do have sine of 2x. If this will be sine of 4x, like 5x, 6x, 7x, we will leave it, but sine of 2x is the double angle formula. That means you may need to rewrite this. Okay? This is the same thing. That's the sine of 2x, 2 sine. Oh, no, that's not 2. Oh, wow, that's my typo. Sine of x, cosine of x. Okay, oh no, that's bad. Okay, and then I can possibly cancel out that too. Oh, I will probably keep that. That's not good. Now, sine of x, cosine of x. And I think I distribute. Oh, wow, I'm carrying this too. Okay. But what I'm saying, just please make sure that you know that sine of 2x, it's simply 2 sine of x, cosine of x. Single x on the right-hand side. Okay. Okay. And then what I did, I have also the solution for cosine square of x, which is identical. The only difference is plus. Okay. I did factor out, I did pull out 1/2 in front, and I'm integrating the same thing. And I think I did rewrite in terms of the double angle, and you can see, since I was copying my formula, I didn't realize that the mistake. Okay, but the same thing. Okay, that means this is the main concept. If you have even exponents, please use the half angle formulas. Okay, and then I have another one, which is a little bit longer, sine to the power of 4 of x. And I can tell you this is probably too long to ask on the midterm or final, but it's good for the homework question. Okay, because you can see we still like the square, as I said, and then we have additional the remaining power, which is 2. In the middle, I will still use the half angle formula, and now I have to square it, which means I will square the numerator and I will square the denominator. Okay. Squaring denominator, I will have 1/4, which I can put in front. Okay, that's easy. And then I still have to square. 1 minus cosine of 2x times 1 minus cosine of 2x will give me this. I'm assuming that you should be good. It's like a minus b squared. It's a squared minus 2ab plus b squared. Right? We remember that formula. That means that's what I did. The first quantity squared, the last quantity squared, and twice the product of the first and the second. Okay, and now I can easily integrate 1. I can easily integrate cosine of 2x. But now what I have, I again have the square. I have the even power. That means what I will do, I will use the half angle formula. But we have to be careful. This is 2x. Can you tell me how can I rewrite this cosine square of 2x in terms of the half angle? 1 plus, and this will be cosine, and who can tell me that angle? Cosine of, yes, thank you. Okay, that means this, I would say that's the most difficult. Oh, okay, that's the most difficult part. And yes, that's what we have. Okay, that's, yeah. Okay, and now I think because I wanted to all of that steps to look clear, I think I did like split for 3 integrals. Integral of 1, integral of 2 cosine of 2x, and the integral of this, which actually I took 1/2 and 1/4, and this results in 1/8. All right, that's what we can see. And now you know the integral of 1, you know the integral of cosine of 2x, and actually cosine of 4x and 1. Yeah, no problem. I can remove this because that's easy. Integral of 1 is x, and I kept the 1/4. Integral of, I can actually cancel out 1 and 2 and 1/4. Cosine of 2x is sine of 2x over 2. Integral of 1 is x, and integral of cosine of 4x is sine of 4x over 4. Okay, and then this is actually, I can keep it. And what else I did? I did distribute 1/8. Okay, we have to be just careful. 1/8. And we have x over 4 and x over 8, which is 1/4 x, 1/8 x, which when we subtract, we will have just, I mean, not subtract, add, I'm sorry, because this is addition. When we will add, we will have, because this one I can rewrite as a 2/8. 2/8 plus 1/8 is 3/8 x. Okay, that means just to explain where this comes from. And we can leave it, I should actually say plus the constancy. We can leave it because sine of 4x, we don't really know the formula. We're not gonna play with this. We might rewrite double angle, but we will leave it just to be consistent to the other form. Okay? Okay, that means just we can see. But of course, all of like half of the slide, it's probably you can do it. Which one is important? This part is important, right? That we will use the half angle formula, and of course the other half angle formula. Okay, for the, let me see, let me highlight this. Yeah, the half angle formulas. Okay. Oh, I think I have one more. Okay, let's go fast through this one. Sine square of x times cosine square of x. Also, it's quite long because we have to use the half angle formulas for both of them. 2 times 2 is 4. I can put 1/4 in front, and then I multiply these two. And also, I am assuming that you know where this comes from, because I have 1 minus cosine of 2x times 1 plus cosine of 2x, which is like a minus b times a plus b. Simply a squared, b squared, and always minus. Yeah? I square the first quantity, I square the second quantity, and minus. Okay? And then we can see we still have square, even power. When it's the even power, we have to use the half angle. And you know where the 4x come from. Okay, and I should even stop now. Yeah, you can definitely integrate from that, but I can show you this step, another one, another one, another one, and that's it. Okay, that means this is the way, but again, the first line is important in that step. Okay? The rest of them is just the practice. You can definitely, what I will do, I will stop there, okay, and I will pause the video and try to complete it, try to integrate without looking. And then you can put the video on and check the final answer. Okay. Okay, that's me. Now let's actually take the same type. Oh, hang on. I just need, because the other part will be, I really need sine and cosine. Wow. Oh my gosh, this is still sine and this is still cosine. Actually, the second pair that we will use, it will be tangent and secant, but we still sine and cosine. I don't know what I moved my slides probably. No, but everything is, okay, that's me. Now we are still looking at the same type, sine of x times cosine of x, taken to the power n and m respectively. Now we will have 1 power odd, 1 power even. Doesn't really matter which one. Okay, and now I did type for you what we will do, but I'm assuming that you will feel it, you will know which way works. Which way, I mean, because we will use the u substitution. That means you don't even have to memorize. Just by doing, you will see, oh, let's let u to be sine of x. Check, if doesn't work, you can check the other way. Let's let u to be cosine of x. Okay, that means what the main message is, that when you have 1 power odd, 1 power even, you have to do the u substitution. And maybe this one, maybe this one. Okay, you will probably see. But of course, let's see how we can speed up the process. Oh, hang on, I have another slide. You can probably see the difference. Both of the powers could be odd, and we will follow the same thing. That means if one power is odd, one even, or if both of them are odd. Because we know if both of them are even, we know what we're doing. It's a different story. We just went through half-angle formulas. But if one is even, one odd, or both odd, we will just do the U substitution. Okay, and you will decide what to do, which way the U substitution. And let's see. Sine square of x times cosine of x dx, which of course one is even, one is odd, because cosine is taken to the power of 1. Okay, and what we will do, you can probably see when I will let, actually, you know what I will do? I will change the view. Probably nothing changed for you. Oh no. I want, okay, maybe now I can write better, which actually we are here. Okay, that's when you, because I have to now start writing. Okay, that means you can probably figure out that when you will let u to be sine of x, then du is actually in that box, because what's the derivative of sine of x? Of course, is cosine of x dx. Okay, and now what we have, sine of u, sine of x. Sine of x was u, which means u squared, and this is du. Okay, that's what I said. You will figure out. If you will let u to be cosine of x, then you will probably figure out that we will not cancel out everything. We will stay with additional sign, and we can't do this. Okay, integral of u squared, it's u cubed over 3, and since it's indefinite integral in terms of u, I will put back original function sine of x, which actually the proper way is to put the cube here. Okay, that's what we can see. It's simply a u substitution. Yeah, but it's fun to figure out which way. Okay, let's look at this one. Sine square of x and cosine cube. And what do you think? Shall we do u sine of x or u to be cosine of x? Yeah, we can, probably you know, again sine, yes, because we see this odd number. That means this odd number, this odd exponent, I can rewrite as a 1, because I will need 1 cosine, since I am letting u to be sine of x, and then remaining even. That means let me rewrite for now, sine square of x, and then cosine square of x times cosine of x dx. Okay? Because that's the 1 power, and I will keep this to be cancelled out. I'm assuming this will be my du, right? This will be my du. But the thing is, if this is my du, the entire integrand, I mean the rest of the integrand, which is this, supposed to be rewrite in terms of sine, since I'm planning to have sine of x. That means I will keep sine square of x, perfect. And now, what about cosine square of x? Who can tell me how can I rewrite cosine square of x in terms of sine? And I will just copy this. I'm assuming this will be du. Okay, what shall I put here? Thank you. 1 minus sine square of x. Very good. Now I think we're ready. Let u to be sine of x. Derivative of u, derivative of sine of x is cosine of x dx. And we can see I have my box ready. It means my integral will be u squared, 1 minus u squared. And this is my du, cosine of x dx. let's distribute, because we still, I mean, you learn integration by parts, that means you know some integrals, the product, but this is the same type of function. We don't really need like additional tools. U squared times 1 is u squared times u squared, we multiplying exponents, u to the power of 4. Okay, u cube over 3, u to the power of 5 over 5. Excellent. And instead of u, we can put sine of x and another sine of x. Okay. Yeah. But we can see the first line, again, the first line is quite important. The rest of them, it's you will do it. Okay, let's look at the next one. Oh, just cosine cube. Who can tell me what shall I do as a first step? Because I see that odd number. Doesn't really matter that we don't have a sine, yeah, as a companion. That's still okay, because I'm assuming. Of course, yes, thank you, Eric. I will do cosine square, which means I will pull out that one and the remaining even. And I will keep this single cosine, because I'm thinking ahead. When I will let u to be a function, probably sine of x. Okay, you can actually think this way. As soon as I boxed at the end, cosine function, I should let u to be the opposite function, which of course I'm assuming cosine and sine are the opposite to each other in terms of some differentiation integration. Okay, that means as soon as you see cosine, let u to be sine. But one more step, if this, if this is my du, I know that I will let u to be sine of x, which means the rest of the integrand, except the box, we have to rewrite in terms of sine, in terms of the opposite function to the box. And yes, thank you, Eric, again. I will put 1 minus sine square of x. Okay, now I can go to my substitution. Derivative of sine of x, of course, cosine of x dx. Really nice. And then I have 1 minus u squared, and this was my du. Okay, integral of 1 is just u, integral of u squared is u cubed over 3. And that's actually boring, but we have to do it. Yeah, if as soon as we know the solution, it's, how am I writing it? Okay, that's the final answer. Okay, that means we're done with cosine and sine. We know what to do if both exponents are even, and we know what to do if both of them are odd, or maybe one odd, one even, because it's the same process applied. Now, as I said, we will have another pair, which now it's the correct slide. Tangent of x times secant of x dx, taken to the power of nm, respectively. Okay, and since for this one, yeah, because they are not exactly derivatives to each other, like secant of x, tangent of x. We have some, we can see this one. We have some extra, like we have some square involved, yeah? That means what we will have, we will just consider two cases. Yeah? If both of the exponents are even, we will do u substitution and we will let u to be tangent. And if, look at now, I'm changing the slide. If both of the exponents are odd, okay, then we will do this substitution. Let me come back. Both even, n and m, we will do u equals to tangent of x. Both odd, we will do secant. And the same, you don't really have to like memorize this, like, oh, you can always try. If it doesn't work, because it's just 50-50. Shall I let u to be tangent of x or secant of x? Okay, that's me, please see, because I really like if students are like even trying and making some errors, but realizing, oh, okay, that's the way. We don't have to memorize lots of stuff. We can just understand. The only thing that we have to kind of know is this relation. Okay, it is Pythagorean identity, but it's in terms of secant and tangent. You probably know this, but I can maybe quickly write something for you. Let's say we definitely know this. Sine square of x plus cosine square of x is 1. Okay, now what I will do, I will take this equation and I will divide each term by cosine square of x. Divide by cosine square, divide by cosine square. And what we have? We have sine square of x plus cosine square of x. It's tangent square of x. Cosine square over cosine square 1. 1 over cosine is secant. You can see, that's how you can figure out. And then it's so easy to solve for secant square. That means just in case, if you will forget if it's 1 plus or 1 minus tangent square, you can definitely, oh, actually that's the same equation. This one we have to solve it for tangent. Okay, which we will subtract 1. But this is the way to maybe remember these formulas. Okay, now let's integrate. What I have? Okay, I have two even, tangent square and secant square, which of course we know that the derivative of, what's the derivative of tangent? Maybe we don't know. Who can tell me what's the derivative of tangent of x? Yes, that's when you can see this is ready. That's ready to be du. The only thing that I have to do, I have to say u, it's tangent of x. Du, it's sitting in the box. Oh no, my writing. Secant square of x dx. Fantastic. Just u squared, and the box is du. U cube over 3, and I will put tangent cube of x over 3. Okay? Yeah, let's look at the next one. Oh, 6 and 4. Both even, that means you probably still remember that I think tangent of x. Okay, but derivative of tangent, as you said, it's secant square. That means I have to pull out the power 2, and the remaining number is 2, because 2 plus 2 is 4. Okay, that's mean what we have. We have tangent to the power of 6, secant square of x, and another secant square of x dx. This one I am saving for du, because du, it is secant square of x dx. Yeah. Okay. One more step, because since I am letting u to be tangent, the entire formula, not including the box, I just underline, has to be rewrite in terms of tangent. Tangent to a power of 6 is correct, but this one, who can tell me what shall I put in the parentheses? And I will copy for us du. How can I rewrite secant square? Is tangent square plus 1 or minus 1? Plus 1. I always have to think. Yes, thank you. That's really good. That's what we have to. Tangent square of x plus 1. Yeah, let's do the u substitution. This is u to the power of 6, and this is u to the power of 2. And of course, this is my du. And what we will do, we will distribute, because we will not mess up the product. We don't really have a product rule. I mean, integration by parts is kind of like a product rule. For product rule for the integration. U to the power of 6 plus u to the power of 8. We adding the exponents. Okay, u to the power of 7 over 7. U to the power of 9 over 9. And I will put tangent. Tangent to the power of 7 of x over 7, and tangent of x to the power of 9 over 9. But that's, of course, extremely easy. Again, this first and the second line are the most important. Okay, and then, oh, I have 2 odd. That means you probably also remember, if it's 2 odd, I will probably let u to be secant of x. Okay, that means what's the derivative? Who can tell me what's the derivative of secant of x? Secant tangent, or tangent, yeah, tangent, secant, the same thing. 1 secant times 1 tangent. Okay, that means you probably know that I have to pull out 1 tangent and the remaining power will be 4, and I have to pull out 1 secant and the remaining power will be 2. Let's do it. Tangent to the power of 4 will stay, secant to the power of 2 will stay. Oh, actually, and then I will have 1 secant, 1 tangent left, but it's important because this is my du. Okay, now since u is secant, I want the entire integrand in terms of secant. Oh, I have a little bit of problem because we like square. So I mean, what I have tangent square of x and square, and then secant square. And I will just rewrite my box, which I really need to keep. This is du. Okay, I will need tangent square of x in terms of secant. Who can tell me this? It's secant square minus 1, Joseph is saying, and I think it is. I have to, as I said, I have to always think if it's plus or minus, but now it is secant square of x minus 1. Okay, I think now we're ready to rewrite everything in terms of u. Secant of x is u squared minus 1 n squared times u squared, and this was, of course, du. Okay, first of all, I will expand u squared minus 1 squared, which will be u to the power of 4, twice the quantities, and 1 squared. Okay, and oh, this is actually du. And then I will distribute u squared. I have to distribute this times this and times this. Okay, what we have u to the power of 6 minus 2u to the power of 4 plus u to the power of 2. And I can integrate, which will be u to the power of 7 over 7, u to the power of 5 over 5, of course I have to keep 2, and u cubed over 3. And instead of u, we should put secant. Okay, I will just, no, I will put actually, oh no, I'm pressing something. Secant to the power of 7 over 7, 2 times secant to the power of 5 over 5, and secant cube. Oh, my writing, it's funny, but we do have the final answer. Okay, let's see this, because maybe you will see this integral, tangent of x times secant cube of x. What do you think? What u substitution we will do? Who can tell me? We can think, yeah, probably secant because they are odd, but again, if you don't remember, always we can try. But I'm assuming that secant x, derivative of secant, oh yeah, and you telling me secant, thank you. Derivative of secant is secant x tangent x dx. That means what I need? I have to pull 1 secant and the remaining will be 2. Okay, which this will be secant square of x, and I have my single secant and my single tangent because it was sitting. Actually perfect. I can just say u squared du. Yeah, because this is du and secant was. What's the final answer? A, B, C, D, or E? It's simply this, yeah? Because we will have u cube over 3, and this will give me secant cube of x over 3. Excellent. You see how nice integrals? Okay, let's see. I have, because I have this one, I have this one, and that's actually 2 integrals. And this will be excellent practice. Excellent. Okay, who can tell me this one? Secant to the power of 4, or actually, secant to the power of 4 theta tangent cube. That's mean this is my first question. Did I cover this type? One odd, one even? I probably didn't really directly cover, yeah? Yeah, Roger is answering. Yeah, Eric is giving us answer, which is really good. Roger is asking. Roger is answering. No, you didn't cover this. Yes, and actually that's true. But do you remember what I said? I don't want you I don't want you to like memorize it, because when I will start like telling you, oh, what to do if one is even, one is odd, will be too complicated. I can tell you this way, that sometimes the combination of these numbers, 4, 3, I don't know, 5, 6, 7, 8, could be even impossible to integrate. Okay, could be impossible. That means you will try probably u sine theta, and no, u secant theta, or u tangent theta, and you will still not like cancel out everything. But some of the numbers works perfectly, and actually we can use both ways. That means when you see one even, one odd, you may try u to be secant theta, or you may try u to be tangent. And I'm assuming this is the case. But if something doesn't work, you can always change. Okay? That means let's see, what do you think? What will be the easier, tangent? Because what's the derivative of tangent? Okay, let me do this. That's what I will do. Because let's say we don't know exactly. Derivative of tangent is, but let's look at this. Then I have to rewrite secant to the power of 4. I have to rewrite in terms of tangent, which will give me square and another square. Yeah, I think we can still do it. I'm just thinking that secant theta will be easier, but just because this is higher power, and then I will have right away, like this will be my u, this will be my u to the power of 4, and I'm fine with this. Pull out 1 secant square, convert. Oh, yeah. Oh, yeah, I know. Okay. I know. I'm just saying that it will be easier, but since I started, I can finish this. I am just saying that probably the 3rd step or the 4th step will be easier if we will do the other way, but it's fine. Let's actually do it. You will do the easiest way. Okay. You will try this. Okay. You will try later this. Okay, but now, since we decided, I think somebody is telling me secant, Eric is telling me secant, but it's okay, I can, no, who said, Roger said, yeah, I can still do this way. That means what we need, we definitely need, at the end, we need secant square theta d theta, because this is my du. That means, yes, we took 2 and the remaining 2. That we have, maybe it's, because I will pull out, I think it's, okay, maybe I am crazy. I think it's not bad. Maybe it's even easier way. Oh, Kasia. Okay, now we good. 2 is 4. Okay, since we letting, that's actually, I think it's good way. Probably both ways will be okay. Okay, my blue part must be rewrite in terms of tangent. That means this is the problem. Okay, that means it's not to the power of 4 anymore. This will stay. I can rewrite this one. And who can tell me what will be in the parentheses? I will rewrite this for us. This is du. In the parentheses, I have to put tangent square theta plus 1. Thank you. Okay, now we're ready. U squared plus 1 and times u cubed. And this is du. U to the power of 5, u to the power of 3. Of course, I am. And now on the extra integration, u to the power of 6 over 6, u to the power of 4 over 4. And now, since we have limits of integration, let's find a new limits. New limits. X was 0, then u is tangent at 0. And actually, what's the tangent at 0? It's actually 0. That means we find, and I can copy the lower limit the same. Now, x was pi over 4. We can see this. Then u is tangent at pi over 4. What is tangent at pi over 4? It's 1. Actually, we like the limits. 1. Let's compute. 1 over 6 plus 1 over 4 and minus 0. That means it's not a problem. Okay, who can add the fraction for me? The common denominator? Let's say 12. 2 and 3. What's the final answer? A, B, C, D, or E? Oh, no final answer? Hey, thank you. I know that it's when it's so easy, you probably don't want to help me, but I need help from you. Okay. That means actually this was fun. This integral was really, really nice one. Okay, that's nice integral because you can see you have to think a little bit, and that's the fun. Yeah. And I don't know if we have time. We do have time. I have one more. Do you think we can solve it? Just in case, if you will see this. Okay, you will tell me what I have to do. I have sine squared theta and cosine cubed theta. One odd, one even, but doesn't matter. Do you think the odd? It's like we like it, but we can rewrite as a single one plus the remaining. Because we need that single, I can rewrite this. 3 sine square theta, cosine square theta, and cosine theta d theta, the single one. That means if this is du, what shall I do with u? U should be sine, the opposite. Thank you. Okay. That means this is cosine theta d theta. 3 sine square theta. Now I need this in terms of sine because everything except my du must be. Okay, what shall I put in instead of cosine square theta? Thank you. 1 minus sine square theta. And now we're ready. 3 u squared, 1 minus u squared, and this is du. 3, still integral, 3 u squared minus 3 u to the power of 4 du. 3u squared actually is u cubed. Really nice, because derivative of u cubed is 3u squared. And this one will be 3u to the power of 5 over 5. And we need new limits. New limits of integration. New limits. For x0, U will be sine at 0. What is sine at 0? Who can tell me? Sine at 0. Oh, Eric, Roger. Okay, sine at 0 is 0. Okay. Now we do have pi over 2, and the new limits will be sine at pi over 2. What is sine at pi over 2? Now it's 1. Really good. Again, beautiful limits. I love 0 and 1, which is 1 minus 3 over 5. 0 will give me 0. The final answer is, who can tell me? A, B, C, D, E, or E? Again, A. Probably I set up everything A, but no. On the test, we will not have everything A. Okay. I can switch off my camera. That means that was actually really good set of integrals that you integrate with me. You helped me a lot. That means thank you. Do you have some integrals maybe from yesterday? We can still spend maybe a few minutes. No, the integration by parts is also fun. I mean, all of the integrals are fantastic. If you don't have any, maybe if you don't have it now, you can post on the discussion board and I will definitely solve it for you. Yeah? Or I will give you some hint maybe, but this session, it's done, everything is, that means probably you don't need additional practice, or you probably have practice with Kasia, but this set of integrals are perfect. If you can go through again and you can make sure that you understand all of them, you